Okay, let me.
So I can see the black screen, but says that Martin has started screen sharing. So
maybe it will appear at some moment, which is strange because I have shared that 1 minute ago.
Yeah, I think you should stop and try again.
Okay.
Sometimes that happens. Yeah, if you stop us sharing and try to do it again.
We'll try again.
It's very weird.
Now it's dark again
It's
for me.
We'll try for the third time, maybe. Any result?
It goes back to black. Are you sure you're sharing the same?
Yeah.
The same document? Okay. Okay. Well, then what I suggest to do is let's jump right to Manuel.
Okay.
and then we switch the order. And then
The other option, Martin, if you want, you can send us the slides to the conference email or even through the chat, and I can share with you, and you let me know.
Okay. How can I do
But in
that?
the while, I think it's a good idea if Manuel starts.
Okay.
yeah.
okay,
That
can you
sounds
see?
good.
Yes.
Yes.
Okay, good. Let me. Yeah. Okay. Let me pin the view so I can also see the screens. Okay, thanks. Okay, thanks all for coming today. Today I'm going to present this paper, Reaction Expectations After Large Depreciations. So I don't think I have to motivate in this particular session the fact that expectations, and in particular expectations about inflation, are important in determining macroeconomic outcomes. But yet, we still don't have a general agreement on how expectations are formed and how expectations react to macroeconomic shocks. That said, we have some recent findings that suggest that consensus inflation expectations, and when I refer to consensus inflation expectations, I refer to the mean of the consensus expectations of a group of people or a group of agents, or maybe the median. And these consensus inflation expectations underreact to macroeconomic shocks and in general to all available information. And I'm going to be more precise about what I mean about available information in a couple of slides. The interesting thing about this and the reaction in consensus expectations is that it holds for consumers, firms, professional forecasters, and even in surveys of policymakers. So despite the fact that we know that the formation of expectations in consumers and firms and professional forecasters are quite different, we can see, or this evidence suggests that the reaction is present across different groups of agents. And this particular story of consensus and the reaction is a support for theories of information rigidities, in particular at the aggregate level. In particular, we are going to talk about noisy information models and sticky information models. So there are going to be some nuances in this support, because if you know the paper of Kovyonov and Gorodnichenko, the support is for the aggregate consensus inflation expectations. If you talk about the paper of Bordalo and co-authors, you're going to see that there is information rigidities at the aggregate level, but then there is some non-rationality within the individual agents. Despite this, there is the motivation that not all the shocks are identified and not all the mechanisms are identified. And that's why we are here in this particular session. And I think in some of your papers, you're going to discuss similar issues. In this paper, I'm going to concentrate on how do inflation expectations react to large depreciations. And one particular important thing about this link between inflation expectations and large depreciation is the fact that when naturally we want to analyze the behavior of expectations to some macroeconomic shocks, we need to focus on shocks that explain an important part of the volatility of the variable that is being forecasted. In this particular case, inflation. And we know that exchange rate fluctuations are an important source of inflation volatility. The other important issue that I'm going to highlight is that large depreciations, if we compare this with the standard movements in nominal exchange rate, are like extreme events. And these extreme events are often associated with declines in output and consumption, and also changes in the real exchange rate. So presumably, agents are going to be more attentive and more, they're going to try to change or revise their own expectations. What I'm going to do in this paper is analyze, again, the consensus expectations conditional on large depreciations, and I'm going to show that expectations underreact. And the second question that I'm going to try to address in this paper is, can we explain this underreaction in expectations with rational inattention models? I'm going to highlight that baseline models may be insufficient. So let me give you like more details of the results. So, you have some idea of what the paper is going to be about, and then I'm going to move on to the specific details of the empirical specification. So I'm going to show that there is underreaction of consensus expectations after large depreciation. This the reaction increased with the average exchange rate depreciation. So if we have a greater exchange rate depreciation, there's going to be more underreaction. And the other important point is that this underreaction is going to be more important in emerging than in advanced economies. This might be at the beginning counterintuitive, because you may think that emerging economies are more in a stable macroeconomy, so more inflation in general. So agents are in general more attentive than in advanced economies, where inflation is lower and the macro stability is higher. Regarding the baseline models of rational inattentions, I'm going to show that this behavior of consensus expectations maybe don't fit the story in emerging economies. And the other thing that I'm going to show is that even if we focus on advanced economies, maybe when we talk about extreme events, these models are not sufficient to explain the deviations from full information rational expectations. Okay. So let me move on to, this is going to be the results that I have so far are empirical results. Then I'm working on the model, so I'm not going to talk about today on how to think about this in a formal setting. So the data that I'm using here is data on forecast of inflation from the firm Consensus Economic. And I have monthly survey of professional forecasters through 30 years. The horizon is inflation at the end of the year, and I have inflation at the end of the current year and inflation at the end of the year ahead. So I have 41 countries and then the euro area. And more or less they are split equally between advanced economies and emerging economies. I think it's 22 and 20 countries. I mean, how are distributed the data. I'm not going to talk about now on data and auto-realizations, but I use the standard sources like the BIS, the CPI from the IMF data set, and then information on other variables like unemployment, etc., from the standard sources. Okay, so first of all, because I'm relating large depreciations with forecast errors, I'm going to talk about forecast errors. I have to identify large depreciations in this particular setting. So for this, I'm going to adapt a strategy proposed by Baron and Gion in QJE, in a paper in QJE in 2017. And the way it works, the identification is this. So first, I compute the nominal exchange rate change for a given country at a point in time. So at a specific month, I compute the nominal exchange rate change. In the baseline case, I'm going to do a cumulative change of 3 months. So suppose I am in June, I'm going to compute since April, May, and June. I'm going to compute the cumulative nominal exchange rate change. So then monthly, at each point in time and country, I'm going to rank the history of nominal exchange rate changes from the highest appreciation to the highest depreciation. And how these large depreciations are going to be identified? It's going to be identified in this way. If the in a particular point in time and country, so let's say in June 2016 in Brazil, if the depreciation that I observe in that particular month is above the X percentile of all previous changes in the exchange rate in Brazil, let's say from the 90s to 2016, this is going to be a large depreciation. One important thing here is not using forward data. So mainly the forecasters are not going to have this information like we have now. So only using past data at each point in time. There is only one refinement that I do, is that at the very beginning, when there is a small sample, I am not going to count depreciations below 1% as large depreciation, and that's because I'm still going to pick up a couple of these very small movements in exchange rate at the very beginning as large depreciation. So I'm not going to count this type of information. Okay. So on the other side, on the left-hand side, what I have is forecast error or inflation expectations, and this is just the actual realization of inflation. Let's say inflation at the end of 2021. And the forecast that I make for inflation in 2021, let's say in September. So then I'm going to have another forecast in October and in November, etc. So this is going to be the forecast error. If K is equal to 0, it's just going to be the forecast error for this current year. If K is equal to 1, I'm going to sum the forecast error for this year, but also the forecast error for the year ahead. So ex post, I can measure my forecast error. Today, I make a forecast for the end of the year inflation in 2021 and the end of the year inflation in 2022. So ex post, I can compute the forecast error that I commit for both calendar horizons. And the cumulative or the median horizon reaction of forecast error is going to be the sum of the two. So let me give you some of the details of the consensus forecast errors, just to give you an idea. When you take all the forecast errors in the sample, are quite high. But this is mainly driven by the inflation that we have in Latin America at the very beginning of the 90s and the end of the 80s. So once you take only observations where the annual inflation in the countries where the annual inflation is less than 100%, which is still quite a high number, you observe that the forecast errors are quite, are short forecast error. This is 0.25 percentage points. And when you basically relate it with the inflation level, you see that are almost zero in most of the countries. This is for the short horizon, and this is for the medium horizon. So takeaway of this table is that in general, professional forecasters seems to tend to do a good job, let's say, in forecasting inflation across the whole sample, and also in emerging economies and advanced economies. So how am I going to relate this inflation expectation with large depreciation? So we're going to have the cumulative forecast errors on the left-hand side. Then I'm going to have a constant, and then I'm going to have my identification of large depreciation. This X is going to define the percentile threshold. So let's say 95, all the depreciations in all the countries are defined by C, made in year T in months M are going to be a large depreciation. I'm going to evaluate the forecast at time of the depreciation identification. And then I'm going to cluster the standard errors by time and country, because there might be correlation across countries and across time. And as I said before, I'm using
10 minutes.
Sorry?
10 minutes.
10 minutes, okay. And I'm gonna not gonna have forward-looking bias, because as I said, I identify large depreciation using only past data. So if this beta, this parameter is greater than 0, what we are gonna observe is as expectation under react. And this is because here, remember that forecast errors are defined the actual inflation minus the forecast. So if this parameter is significant and positive, we are going to have an underreaction after large depreciations. The opposite is true for overreactions. So let me give you the main result of the papers. I have some robustness checks, and I did like I divide the sample in different ways, but we are not going to have time to discuss this, at least in the main presentation. So what you observe here is the size of the depreciation. So suppose that I have the 95th percentile of all depreciation in the countries. Suppose that I have the median horizon, the cumulative horizon. What we have here is that the underreaction is almost 4 percentage points after a large depreciation in the whole sample. In the short horizon, which means only the current year, is almost 1 percentage point underreaction with respect to the inflation level in the whole sample. You observe that this is increasing with the average size of the depreciation. And the other thing is that this is more important in emerging economies than in advanced economies. So in emerging economies, after a large depreciation of 95 percentile, so I'm taking the highest depreciation, large depreciations in Latin American economies and some Asian economies that I have in the sample, and then the reaction of expectation is about 7 percentage points. And in the median horizon, the annual inflation rate is about 20%. So it's quite a big number after large depreciations. Still in advanced economies, it seems to be short, but it's significant, and we observe this underreaction after large depreciations of inflation expectations. So once I show that there is this underreaction after large depreciation, the natural question is to think about, okay, can we explain this result with the baseline models of stick information and noise information? Because as I said before, there is support for these theories, given the fact that we observe underreaction under not only under this shock, but under all other shocks like oil prices or even unemployment rates, unemployment shocks, for example. So I'm going to use a test of Kobielak and Goronichenko proposed in 2015 to test the fire hypothesis. And in this case, the crew, I mean, the best or the most important thing in this test is that forecast revision are going to account for the reaction of the agents to all new available information. So instead of relying on a shock, we are saying, okay, the forecast revision should account for any information that the agent have during this process. Again, I'm going to compute cumulative forecast revisions in the same way I compute cumulative forecast errors. So the forecast revision in the particular current period, which is going to be the difference between my forecast in September and my forecast in August. And if cumulative, is going to be the difference in the 2 years. Then how I'm going to relate this in my empirical specification, I'm going to add this term here, which is forecast revision. This is the test that Kobielak and Goronichenko proposed. The nice thing about this test is it's coming from theory. So it's derived from the baseline models of rational inattention. The prediction of this model is that if this phi is positive, there is an underreaction on forecast on inflation expectations. And two more things that we can test and the model predicts is that the constant should be 0 and no other variables should have an explanation in the forecast error. So meaning that we can explain in Bayes' models of information rigidities forecast errors only with this particular term being positive. So let me show you the results. So let's concentrate on advanced economies. And for a while, let's concentrate on forecast revision, this 0.423. So this means this is positive, and this means that there is an underreaction of large depreciations in general, of inflation expectations. And the result that you have in Kobielak and Goronichenko with a sample of only advanced economies and let's say normal times, not extreme events, is now no other variable has some predictive power. But once you add this extreme event, large depreciation has also a predictive power. It's like there is an excessive underreaction during these periods of large depreciation. So even above the one that forecast revision can account for. When you go to emerging economies, the story is even more interesting because when you take out large depreciations, forecast revisions are pointing to an overreaction. Sorry. This means that in general, what we observe in emerging economies is overreaction in inflation expectations. That said, when we introduce large depreciation, we observe that still there is under reaction of inflation expectations to large depreciation, and even is quite high in these particular economies. So these results are pointing to the fact that baseline models of rational attention might not account for the fact that there is overreaction, and this is contrary to the theory of rational inattention, where we have particularly all underreaction. And also, even if we have underreaction, like in the case of advanced economies, when you study an extreme event, at least when you study large depreciation, there is an excessive underreaction. So let me conclude, because I think I'm running out of time. What I show in the paper is that there is an underreaction in consensus expectations after large depreciations. This underreaction is increasing with the average size of the exchange rate depreciation, and also is more important in emerging than in advanced economies. Rational inattention models may be an insufficient predictors under extreme events, because as I show you, the only parameter that should be important is the one that relates forecast error with forecast revision in the baseline models of rational inattention. But here we observe that if we introduce another variable here, namely this extreme event, large depreciation, this also have some predictive power. Unless there is less support for models of information rigidities in emerging economies, where we observe, irrespective of this extreme event, namely large depreciation, we observe overreaction in inflation expectations. Thank you.
So I'm going to start I'm going to allow myself to take a moment to ask a question. And then if some others have questions, I'll let them ask too. But so I'm a little confused on the language and on, on what you're taking as kind of a baseline or a benchmark deviation from full information rational expectations. Because it seems to me that, in a sense, rational inattention that you sometimes treat as your benchmark alternative, it's a very different story than noisy information or kind of information rigidities. So what exactly are you thinking about?
I totally understand. So I should probably have said that I'm using rational inattention in nowadays some people use rational attention in order to put noise information models and also stick information models. But I know that at the very beginning there was like the division between rational attention models and the way that we call the different models. So here, when I'm talking about rational attention, to be precise, I'm talking about baseline model of stick information, Mankiw and Reis. So whether you have a set of agents that update all the with all the information like a rational forecaster, and then you have a subset of agents that they don't actualize the information, and then the noise information models where you receive a noisy signal, like in the case of SIMS and Cursor. So here the word rational attention, I'm using this word to account for these two types of models. And why is that? Is because the test proposed for Kovion and Gorodnichenko in this paper shows that for both stick information models like Mankiw and Reis and noise information models like SIMS and Woodford, both have the same prediction, that forecast revisions explain or have some predictive power with respect to forecast error. And this variable should be the only one that have some predictive power. And that's why, and thanks for the question, but because I think it clarifies. So here, rational expectations meaning these two models. Rational inattention, sorry, means that I'm talking about these two particular baseline models.
I see, thanks. So I could ask a lot of other questions, but for time reasons, I will refrain unless someone else wants to chip in with a quick question.
Maybe one question. What role plays memory here? Because if you are in Argentina, you have this depreciation once every 5 years, and if you are in Germany, you have this almost for I propose never.
Yeah. Yeah, I checked whether you know, having one of the robustness check that is having a repetition of these events give you some learning, and then you under react less, let's say, in the future. When you take the whole sample and you would divide the sample in emerging economies and advanced economies, I don't find anything. So then the reaction is present and there is no learning story behind. That said, Argentina is a particular case. I'm also from Argentina, and I start with the opposite intuition that people overreact in large depreciation, which is the case in Argentina. But then when you, in the particular case of Argentina, you observe that there is overreaction. But when you consider the whole emerging economies, at least the one that I have in the sample, and the advanced economies, what you observe in general is underreaction. And I'm checking this if there is some learning, at least in aggregate terms, or at least in the, even if I divide the sample between emerging and advanced economies, I don't see any effect or any learning or any memory of previous events.
Thank you.
Welcome.
All right, so let us continue with that. Okay, so in the meantime, Misha arrived, so let's continue with Misha's talk. And so Misha, you will have 20 minutes, and then that will be followed by Martin and myself.
Great. I will need the sharing.
So
all right.
Juan, conference support, Juan, could you please add Misha as a co-host? Okay, now it should work.
Yeah.
Okay.
Great. 1 second. Yeah. So I'm Mikhail Galashin. I'm a graduate student at UCLA Anderson, and I'll be talking about a paper with Martin Kranz from Stuhle from Berkeley on the effect of macroeconomic expectations on credit card spending. And I'll be on the postdoc market this year. Basically, our motivation with this paper is that like a lot of models and a lot of policy work assumes that if like inflation or exchange rate expectations change, then people should change their consumption patterns in response to that. For example, like there's a quote from the Federal Reserve Board: when central banks provide forward guidance, individuals and businesses will use this information in making decisions about spending and investing. And it's in this case, it's very important to ask what are those who are those individuals in these businesses, and to what extent do they adjust their spending patterns? And there is very little causal evidence about that, and there's some survey data and sort of incoming papers with like matching survey data to consumption data, and we're like a part of this wave. So here is our field experiment. We use a partnership with a large commercial bank in Malaysia, about basically the largest in the country, to link the expenditure data with a survey where we use an information provision experiment to get a variation in inflation expectations. So we administer the survey over the phone, and we randomly provide expert forecasts on inflation, exchange rate, or both. And we like for each respondent, we measure posterior beliefs and look whether those shifts affect consumption in the credit card transaction data. And to give a preview of results, consumers do update their beliefs, and there is, however, we don't see much of an action when we go from beliefs to consumption data, and we have a few mechanisms that might explain that, and I'll talk about that a bit later in the talk. And so and we contribution to like literature on information efficiency and inflation. There is a large and as well as other outcomes. There's like a lot of evidence that people on how people actually process information. We also contribution to this second wave of literature that like takes this information processing and gets it to the data and actions, both for for macro and for consumption data, but also like for housing markets and this kind of stuff. And what we bring to the table is like our setup is a small open economy, which since we're the conferences supposedly in Latin America might be closer to your heart. So we are exchange rate is very important for Malaysia. It's like an oil economy, and so we are able to give some evidence on these type of expectations, as well as the effect of this type of expectations, and more general literature on financial expectation and financial decisions. Yeah, so basically we write to make sense of what is going on in our exercise. We write a partial equilibrium time model where people decide whether to spend on perishable or durables, and tradables or untradables, and we arrive at three main predictions. First is that if you spending on durables should increase in your inflation expectations. Second is that spending on tradable durables should increase with the expected exchange rate depreciation if there is some pass through to inflation for tradables. And that borrowing should also increase because people in order to make this adjustment, people have to move their balance sheet a bit. So yeah, and our experiment is designed to test these propositions, and let me get to the research design. So what we do is for each consumer, the bank client, we observe his pre-treatment behavior, how much does he spend on this stuff or that, and then we make one survey phone call where we first elicit prior beliefs. Second, we give information, expert information on either on the exchange rate depreciation or on inflation or on both, and this variation in whether you get both or just one will allow us to identify the causal impact of each of those beliefs.
10 minutes. So you have 10 minutes left.
Okay. Okay, I'll try to speed up. Yeah, so and then we elicit posterior beliefs. Then we have a battery of survey outcomes in line with what Michigan Survey of Consumers does. And then we observe post-treatment behavior of all the consumers. Yeah, so basically, as a first descriptive claim, I should say that there seems to be a lot of value in this exercise of linking actual spend into survey data, because although survey data has some predictive content and does explain some, like, is somewhat significant if you try to predict change. If you try to predict like actual spending with an analogous question on survey data, but the correlation is relatively is very weak. So there is a lot of room for discrepancies. Yeah, and the second set of results is on belief updating. So we have two types of beliefs: the exchange rate and the inflation. And the way, let me explain what goes on the graph. Basically, on x-axis there's a gap that you had before you gap before the signal and your prior knowledge that you had before before the survey, or in the first part of the survey, and the y-axis is how much do you update after the information provision. So if you don't care what we tell you, like, the line should be completely flat. If you adjust completely, it should be like a 45 degree line. And what we see here is that people learn more if they are actually provided information. So there is some spurious turning, which is like the slope of the gray line, but information is actually important. People take into account. However, there is less learning for the exchange rate beliefs, and this makes our experiment for the exchange rate quite a bit weaker. Yeah, so, and to look at these effects and bring it to the transaction data. So here is a reduced form estimate of the effects. Basically, we don't see any significant changes in consumption in response to the beliefs, or have significant effects on beliefs. So, and if you look at the IV estimates to make sense of like what those elasticities are, if you change like person's inflation expectation by 1 percentage point, it looks like that the highest possible effect that we can roll out is around 0.1 standard deviation for all outcomes, at most 0.1 standard deviation for all the outcomes. And it's, for example, it's way lower, way smaller for total consumption. And if you look at the exchange rate depreciation, as I said, our experiment is quite a bit weaker, and estimates are quite a bit less precise. And we have a bunch of negative coefficients, which we interpret as something just like a result of noise. And we repeat this exercise, like what's the highest possible possible actual value of the of the elasticity if like with our data, and we arrived that it's also like on the order of 0.12, 0.13 of the standard deviation, and it's around 0.4 for that. So we have like essentially don't have much precision for that. Yeah, and also let me go through the mechanisms that we've considered when we are explaining this, like basically not null result. So one hypothesis is that maybe agents intend to change their behavior, but they don't follow through on their like supposed choice. But we see evidence against that, because information doesn't affect not only actual expenditure but self-reported data. So if you would want to change your behavior, we would see it in self-reported data right after the information provision. And the second channel that we consider is optimization friction. So suppose people don't pay that much attention to changes in inflation that are lower than some threshold, depending on like how that they have some importance threshold. We actually don't see if we've ran a complementary survey on sort of subjective models to test that. So if we basically give people scenarios of what of like the inflation and exchange rate depreciation to consider, and we actually have effects that are very consistent with what we observe in the data, that basically people not only don't change, they wouldn't change even if we explicitly give them a scenario where like there is a 10% inflation. Yeah, and so the mechanism that we think might work is income effects. So it looks like people become less like if for example, if inflation increases, people become more pessimistic about their future real incomes, and that seems to drive the expenditure down. And another mechanism is consumer sophistication. So maybe people just don't have like a mental link between inflation and exchange rate and what they're doing on day-to-day basis. And we are currently piloting an auxiliary study for that. How much time do I have? Am I in line with the schedule?
1 minute. 1 minute.
Great. Okay, so to conclude, we show experimentally that consumers update belief in response to macroeconomic information. However, it doesn't look like people are switching their behavior much in response to these updates, and we rule out a mechanism on like short-lived. We rule out a mechanism on short-lived impact and optimization frictions. However, and we think that likely explanations are either the changes in expected real income or lack of consumer sophistication. We will work a bit more on separating the two. Yeah, so that's all I had
Great.
for today.
Thank you so much, Misha. So I will take the charge here and move right on for the sake of time to Martin's talk. So Juan, could you please share Martin's slides.
Okay,
Thanks, Nisha.
thank you.
Do you see what I am trying to share, or doesn't work?
No, for me, I just see again
Okay,
that you have started screen sharing, but Juan will put up your slides.
okay.
So now I see something. So I don't know whose this is.
Yeah, I can see everything.
Okay, go. Well, can you go to slide 2? Maybe in the interest of time, I will try to summarize this. Well, what is the question that we try to answer here? We have basically we have inflation, we have expectation, and our null hypothesis was Kagan, of course. And the question is, we have expectation, but what are the bounds of this expectation in reality? How this expectation that every agent has developed in reality? Because we have asset price inflation, we have quantitative easing, we have populism, we have breaking of fiscal restraint. How are this expectation that each agent has working in the real economy? And can you go to slide 3? This is the question that we try to answer. And we go to Kagan, and Kagan has basically explained his model by setting expectations, and later on we have some development that try to play as a variable that also explain rates of inflation by income. Can you go to slide 4? Thank you. And basically all this development in the 60s, 70s, and 80s, what they do, they put together expectation, money demand, and inflation, and basically they have a closed loop. And so all actors develop all his expectation, and therefore the upcoming inflation is developed in this closed loop, and they do not show. They try to show that velocity is stationary, but this stationary does not mean that this is insignificant, and therefore we try to work. Can you go please again to slide 3? Because we have this this explanation that we do not see here in the Kagan explanation in the last equation. We do not see anything related to velocity, and this is the main feature that we will take. Can you go to slide 5? Thank you. And what is the intuition here? Essentially, we may have shocks of velocity here, and the shock of velocity go through work with shocks on expectation, and this shocks on expectation maybe, that is the hypothesis of this work, may work correlated by institution. To be precise, to just give 2 examples, this expectation are correlated by, for example, the deficit which is done by the government is correlated by the institution that work in the Congress, which may contract or expand this deficit, which works works in the inflation mechanism, and the other thing is that all the agents in the economy have the work in a web of contracts, and also this contract web also corrals and allows to validate or not validate this inflationary expectation. Can you go to slide? In the interest of time, can you go to slide 7? This is slide 8. 7 should be slide 7 is the prior one. 6, property rights and so on. Which is which is the main institution that work to corral this expectation of all the institution that we have in the economy? This is of course property rights. Agent to basically look at his property rights, and what did they do? They acting in consequence. For example, if they expect high inflation, they try to defend his property rights, and this work throughout all the economy. Okay. Slide 8, please. This is slide 8. Where do institutions come in? Part 3.
Which one do you want? Excuse me.
Slide 8.
8.
Where do institutions come in? Part 3.
This one.
Thank you. And this is a visualization of it. In if we have poor institution, we have poor property rights, and this creates difficult informing expectation, because information is more difficult to obtain. So we have this figure of the volcano. We don't know where we are. Whereas if we have stable condition, our horizon is clear, and we see what we can do, so we can form expectation with in a stable environment. So slide 10 would be good to show now. Exactly. Thank you very much. So this is the model. This is the model explanation. We have something like that we call a pure monetary inflation, which is based on the expectation of the development of the money market, which is the usual approach. We have money and supply imbalances, and somehow people form the expectation of inflation in the sense of forecasting this, or looking of past realization of those imbalances. And here we incorporate, based on taking the structure of our Olivera model, we incorporated here that expectation are correlated, they have a strong restriction by the institutional strength, because the institutional strength, for example, think of Japan. If you forecast a high inflation, this will never happen, because the contractual framework of Japan does not allow to do that, because you cannot set the price very much higher. You will be out of the market very quickly.
10 minutes. So you have 10 minutes
Thank you.
left.
So this is the basic model. We have a pure monetary inflation, which is based on this is the main idea. You can forecast your inflation based only in relation to the money markets, to say, or you can incorporate other aspects such as institutional strength and other relative prices and so on. But all this is interrelated. There is a loop. You may have agent that forms expectations, and the inflation may be realized only on the basis of the monetary imbalances, or you can have an agent that includes other aspects, notably institutional strengths in his forecast. This we can go to slide 12. Thank you. So we have a yes, this one. So we have a model, and we are able to test the data with a VECM model. This is based basically on the Oliveira model, and just take the variables and take some proxies. We take as an expectation proxy, we take Google searches, which is kind of a novel thing that we are trying to perform here, which is, can you go to slide 14? So this is expectation using Google data. We just use Google data to predict expectation. This is monthly expectation, and we have basically got a very good fit of it, of this fit using expectations for the example of Poland, which is nowadays it's basically a low inflationary country. Then we can go to slide 15. So we have slide 15. It has Venezuela and the US. For Venezuela, we took the second difference, not the first difference. So we take the acceleration of the price index, not the first difference of the price index. And basically, what we see is that the real inflation, which is the brown line, is stacked between these two measures of an inflation forecast, which takes into account the institutional strength, and the other one that takes only the monetary variables. This is there is a relation between the two by a parameter which is explained in the paper, but it will take too much time. And we are able to see that basically for Japan, for example, and the US, and this is the case of Venezuela, we can predict for Venezuela the trend of the hyperinflation, which is nowadays going on there. Can you go maybe to the slide prior to that, which has the examples of US and Japan? Exactly this one. Here we have we solve this the differential equations that we have here for the case of the US and Japan. And what we see, we have also this pure monetary and this institutional this feedback, and we showed that basically this is monthly inflation, and we have a near good fit of the real inflation between this band. We can think of this the measure of this institutional feedback and the pure monetary inflation as to benchmark around which the inflation fluctuates, and in the sense that the agent formed their expectation based of some of this measure on one of this measure. And just to close this somewhat chaotic presentation, sorry about that, but was not able to hand myself the slides. Basically, we have our question was, well, how is this how we have this expectation, how is the developing of this expectation bounded by what? And we find that property rights and institution is at least interest try to look at for this bounding. And we took a model by Oliveira and applied to this. This is not exactly Oliveira models, but it's because we took it to the second difference. Oliveira work with the first difference, but it's an application, clearly an application of Oliveira model. And the main question that we will try to answer in our next research is if they are better empirical testing of the model to do, because we use a proxy for institutional strength that use some index which are internationally viable, but they may be others measure that are still better. For example, some measures of institutional strength related to characteristic of the central banks and other characteristic to inside money and so on. So we are working on this, and we'll try to make progress on that. Thank you.
Thank you very much, Martin. So Juan, you can stop the share. Thank you. All right, then to close this panel, I'm going to give a lightning version of my talk, trying to respect the time of the panel. So can you see my screen?
Yes.
Great. All right, so let me talk to you about monetary policy and anchored expectations. And before I get started, let me note that these are my views and they don't necessarily reflect the views of the ECB, my employer. All right, central bankers talk a lot about anchoring. And in fact, they've been talking about how important it is to anchor inflation expectations for a very long time. But the issue with this constant conversation around anchoring is that we don't actually have a good notion of what it means to have anchored expectations, or to have unanchored expectations for that matter. And so in order to be able to analyze monetary policy in conjunction with the unanchoring of expectations, we need some kind of theory of anchoring. And so that's what I propose to do in this paper. So I propose a new model of expectation formation that gives rise to the notion of unanchored expectations. And in particular, the model is going to formalize the idea that the more sensitive long-run expectations are to short-run fluctuations, the more unanchored our expectations. And I'm going to embed this theory into a general equilibrium new Keynesian model, which allows me to study the interaction between monetary policy and unanchored expectations. And this I'm going to do within the context of a model in which I quantify the unanchoring mechanism using data on inflation expectations. And in the so calibrated model, I'm going to derive the optimal monetary policy. Okay, and the key takeaway from this research will be that monetary policy will find it optimal to anchor inflation expectations to the inflation target. And I'm also going to be able to tell you how to do that. What the central bank will need to do is when setting the interest rate, it will need to respond very aggressively to movements in long-run inflation expectations. All right, so I'm going to skip the literature for the sake of time. I'm going to dive right into the model. Okay, so the model will be comprised of two parts. One I call the new Keynesian core, which is going to be perfectly standard. And then there will be the expectation theory. That's where all the action is. So I'm actually going to skip the discussion of the new Keynesian core. I'm just going to point out that you can summarize the new Keynesian core by yielding obtaining two aggregate relationships that explain how the observables of the model, so the output gap, inflation, and the interest rate, relate to each other and to expectations of the future. Okay, where note that there are two exogenous disturbances in the model. Rn is a natural rate shock, and U is a cost push shock. Okay, and so far the model is completely standard, except for these expectations operators that are going to be a particular kind of non-rational expectation operator, and that's what I'm going to turn to next. Okay, so in order to be able to formalize anchoring, I will need to have some notion of long-run inflation expectations. And to model that, I will rely on adaptive learning. So the informational assumptions behind this E-hat expectation operator is going to be that agents do not understand that they are identical. So while I'm going to assume that firms are going to be identical across one another and households as well, they are not going to know that, okay? And that's going to mean that they don't internalize that the expectations of agent I are going to be identical to the expectations of agent J, which is actually going to coincide with the aggregate expectation, but they don't know that. And what that implies is that agents in this model are not going to be able to compute the aggregate relationships of the model. So in particular, they are not going to be able to compute the Phillips curve. So they don't know what the true law of motion of inflation is. But they still need to form some forecasts of inflation. And so what they're going to do is they're going to postulate an inflation process. And I'm going to assume that it's going to look this way. So what this means is that the inflation expectation that agents form at time t-1 is going to be what it would be under rational expectations, plus this novel intercept term, pi bar, that is going to be the agent's expectation of average inflation. So this term would be 0 under rational expectations, and allowing it to be non-zero and to move in time essentially amounts to the assumption that I allow agents in this model to entertain the possibility that average inflation may be non-zero, okay? So this long-run inflation expectation, pi bar, is going to play a key role. And so let's turn to how it evolves next. Okay, so this is just a repetition of the same equation I showed you before. You can think of this equation as describing the one period ahead inflation forecast of the agents in the model. And so using that equation, you can define the one period ahead inflation forecast error, ft/t-1, it's just the difference between realized inflation and the agent's previous period expectation of it. And then you can write the update for long-run inflation expectations as the following. So the agent's current long-run inflation expectation is their previous expectation plus an update term that is comprised of the forecast error that essentially measures how well did my beliefs do this period. And then the weight term, k, which is the learning gain. It's a variable between 0 and 1. Okay. And so this is where my main intervention comes into play. So in the adaptive learning literature, there are two general alternatives for the gain that people usually use. One is the decreasing gain, in which the gain is just some exogenous function of time. So here T denotes time. And the other is the constant gain, in which the gain is just some exogenous constant. Instead, in order to have a model-based notion of anchoring, I'm going to assume that the gain is endogenous. So I'm going to endogenize this gain. I'm going to assume that the gain is some function g of the most recent forecast error. In particular, I'm going to assume that this function g is a smooth and continuous function and convex. Okay, and what that's going to give me is that whenever agents see large forecast errors in absolute value, then that's going to drive up the gain. So their long-run inflation expectations are going to become more sensitive to forecast errors whenever they make large mistakes. Okay, so let me illustrate that. This is going to give me this time-varying sensitivity of long-run expectations, and this is how it works. So recall the long-run inflation expectation evolution. Suppose now that the gain would be very high, so 1. Okay, that would mean that whenever you see some forecast error, that forecast error maps 1-to-1 into the evolution of long-run inflation expectations. Okay, in this case, I'm going to talk of highly unanchored expectations. If instead the gain would be 0, so the other extreme, then you see that long-run inflation expectations are just constant. So there is no pass-through between forecast errors and long-run inflation expectations. In this case, I'm going to talk of perfectly anchored expectations, which nests the rational expectation case. Okay, and so basically what is going to happen in this model is that depending on the realized forecast errors, you're going to have a time-varying sequence of gains reflecting periods of better anchored or less well-anchored expectations. Okay, so in the interest of time, I'm going to skip a whole bunch of things that otherwise would have enriched your lives. I will also, unfortunately, skip the estimation part where I quantify how unanchoring plays out in the data. And instead, I'm going to go right on to the optimal monetary policy. So what I do is I estimate a form of the gain function, because this gain function, I have not specified what it looks like. And so I just take it from data. So I estimate what it looks like from data. It introduces a lot of nonlinearity into the model. And so therefore, I solve the Ramsey problem of the Monetary Policy Authority using a particular kind of global method algorithm. And so the problem that I solve is to minimize the central bank's loss function, which is the standard loss function from textbooks, by choosing the vector of observables and the endogenous states, so long-run inflation expectations and the gain. Okay, subject to the model equations, and in particular, subject to the evolution of expectations. And so what I'm going to show you next is a numerical approximation using these global method techniques to the optimal interest rate function. So focus first on the left panel. This shows you the optimal policy function, so the interest rate that the central bank chooses as a function of the states of the model. So long-run inflation expectations and all about the bunch of other states that I'm going to keep fixed at their means. Okay, and what you see is that, for example, if long-run inflation expectations start at the steady state, so at 0, and then for whatever reason they drop by, say, 5 basis points, then the optimal policy function prescribes a response of lowering the interest rate by 250 basis points, so extremely aggressively. Okay, why is that the optimal thing to do? Well, now look at the right panel. So this shows you a histogram of changes in long-run inflation expectations under simulations of the model in which the optimal policy is in place. What you can see is that that distribution is concentrated really tightly around 0. In other words, what is happening here is that the central bank, by responding really, really aggressively to fluctuations in long-run expectations, is able to anchor expectations very tightly to the inflation target. And so now the last thing that remains in the last minute that I'll take for myself here is to understand why is it good for the central bank to anchor expectations. And to do that, let's look at impulse responses of the model. So here are impulse responses of inflation, the output gap, and the interest rate, to a one standard deviation cost push shock, when policy does not follow the optimal policy, but instead follows a Taylor rule with standard parameters. Okay, and I'm plotting several cases of the model here. So in blue solid, a strongly anchored case, by which I mean that at the time that the shock hits, the gain is very small. It's at or below the 10th percentile of its simulated values. Then a weakly anchored case, this purple dotted, and an unanchored case, this yellow solid dotted line, by which I mean that the gain is very high when the shock hits. So it's at or above the 90th percentile of its simulated values. And just for comparison, I'm also plotting a rational expectations version of the model in red dashed. Okay, so you can see two things. One is that this shock is an IID shock, right? You can see that by the fact that rational expectations responses revert back to the steady state right after impulse. Okay, but not in the anchoring model, because in the anchoring model, agents, when the shock hits, agents for a time think that, oh, maybe average inflation has changed. Okay, but more importantly, the more unanchored expectations are, the bigger the deviations from steady state, and not just after impact, but throughout the full transition path back to the steady state. In other words, the more unanchored expectations are, the more this amplifies other shocks. And this is the reason why the central bank wants to anchor expectations, wants to make sure that shocks, exogenous shocks do not get amplified by the unanchoring of expectations. Okay, so that was a truly lightning version of my talk. So let me conclude. So what I have attempted to do here is to present the first theory of monetary policy in a model with potentially unanchored expectations. What this relies on is a model, a theory of expectations that provides a notion of unanchoring that comes from a model. Okay, and that notion is really a formalization of this idea that unanchoring represents the sensitivity of long-run inflation expectations to short-run surprises. Okay, and with such a model, what you see is that optimal monetary policy anchors inflation expectations, and it does so by responding aggressively to fluctuations in long-run inflation expectations. All right, we're out of time, so thank you very much for your attention, and I'll conclude there. Thanks so much. All right, I also think that with that, we sort of are at the hard deadline of our panel, if I'm not mistaken.
Seems so.
So with that, let's give us a couple of minutes to ask questions. So if anyone wants to ask any questions to any of the presenters that I have suppressed so far.
I have, I can start. Laura, I think I enjoyed your presentation. I was thinking that if I correctly understand and if I remember well, the way you endogenize this change between a constant gain and a decreasing gain is quite similar to the way I think Marcetta Nicolini did in this paper, Recurrent Hyperinflation. When you have an hyperinflation, you want to put more weight on the current information, so you switch to a constant gain. And when in normal times you switch to a decreasing gain, right? So, and my question is going back. So probably I missed it in your presentation. Is going back to the idea of what is an anchor of expectations. So you may think of, okay, like Bernanke says, is zero. You don't change your expectations with like your new information. But also, and that's gonna be my question, is like you could react to the information that you receive, but still be around the target. Or you can also be anchored, let's say, that could be another definition, like below or above the target. Let's say, for example, poor households in US, that they tend to have higher expectations than the target, but for a while, it could be, it's kind of anchored but above the target. if I understand well, in your model, you are also saying that this is not possible. Like the long run expectations should be always around the target, and you are like discarding the possibility of having anchor expectations above or below the target.
So very good point. So let me start with the Marcet and Nicolini, the relation to Marcet and Nicolini. So absolutely, this work is in line with the framework of Marcet and Nicolini, which potentially inspired a paper that is even closer related to my work, which is Carvalho et al. Anchored inflation expectations. That you can think of that paper as essentially a mapping to Marcet and Nicolini, but with slightly different structure. And my paper is really in that line of literature, except that I introduced some changes with respect to the way that both of these papers have modeled this idea of choosing between essentially disregarding all data completely, so a particular kind of constant gain, versus looking at the full past sample, which would be a decreasing gain. In my specification, by construction, the agents don't choose between two discrete states, but they are in a continuum between those. And I think that the advantage of that is that you really have this smooth measure of unanchoring that you can map directly to data. So that's the advantage. And then in terms of the contribution to this literature, to the best of my knowledge, these previous papers do not look at the interaction between monetary policy and anchoring. So a big contribution from my paper is to say, okay, let's think deeply about the anchoring mechanism, and let's also put it in a general equilibrium framework so that we can study what it means for monetary policy. So that's how I see the relation to those papers. That's an excellent point. And then the other point about the level of anchoring. So it is true that in my presentation, I do focus on anchoring to the inflation target, but that's only because that's what I observe the central bank as targeting. That's what comes out of the optimal policy. But it's not a possibility. So an anchoring to another level is not a possibility that my model rules out. It could happen, but the policy authority does not allow it to happen because it is not the optimal policy. So yes, and that's an excellent point, because in the data, truly, especially for households, their expectations seem to be, so especially in the US, their expectations seem to be anchored, if anchored, I would say, at a much higher level. So 4%, 5%, something like that. And I would be interested in looking at that more closely in future work. Is there some separate dynamics coming from expectations being anchored at the wrong place? It's not trivial, because one could say that, maybe as long as they are a little bit off, they're at least having inflation off their radar. So maybe it's not a problem, but it could be that it impairs the central bank's ability to move expectations. So in that sense, it could be a problem. So it's not trivial. So it's interesting to look into. Thanks for both of those great points. All right, I think we're stretching the patience of our hosts at this point. So with that, I would like to thank you all for your contributions and for struggling through the technical issues. I wish a good morning to the West Coast and good evening to everybody else, I suppose. All right. Take care, everybody. See you next time.
Nice to meet you.
Take care, everyone.
Bye-bye.
Bye-bye.
Yeah, great time.